Hai, Assalamualaikum warahmatullahi wabarakatuh. I'm Muhammad Daniel Aiman bin Muazzadi and I will present the Chapter 1, Identify the type of reaction involved, the reactants and the product. So we know that the biodiesel is widely utilized in the industry and may be made in a variety of purposes, including a thermal cracking, direct vegetable oil mixing, trans-esterification and also esterification itself. So biodiesel, also known as a fatty acid methyl ester flame, that typically used in a high heating system that require a lot of energy. So among all the crude oil source, so we choose that palm oil has gotten a lot of attention lately. So because it widely cultivated in tropical countries like Malaysia, Indonesia and Thailand. So we choose type of reaction which is esterification of palm fatty acid, FFA. For the reactants, we choose the heptadecanoic acid plus methanol. So the product will be the methyl heptadecanoate plus water. Okay. For the chapter 2, suggest one solid catalyst for the reaction, justify, and compare it with other catalysts. So we choose ZnAl2O4 sulfonated mesoporous as the solid catalyst for the reaction. Because it is a sophisticated technique that ideally suited to the generation of methyl ester. It also have favorable properties such as a large pore volume and a high surface area. So the sulfonated mesoporous also classified as a heterogeneous catalyst, which is highly active because of the existence of the strong acid site strength, limited active site leaching, and the minimum unwanted site reactions. So we compare sulfonated mesoporous with other catalysts, which is HPDV, SSFBI, and also SAMCM41. So the sulfonated mesoporous has the largest surface area that obtained from the Brunner and Taylor method, which is 352.39 m² per gram. We also have the pore volume of sulfonated mesoporous is the smallest, resulting in the exceptional selectivity. And the average pore size is the second highest of average pore size compared to the others that recorded at 3.1 nanometer. And finally, it was discovered that the sulfonated mesoporous catalyst has up to 8 cycles, which is the greatest value among the other catalysts.
Assalamualaikum. My name is Haris Molinari and I will be discussing Chapter 3, the preparation procedure of the proposed catalyst. So for the catalyst preparation, the first step which is to have a D-glucose template assisted approach, which uses the polymetric mesoporous ZnAl2O4, which is a zinc aluminate catalyst, which is then hydrothermally produced in the presence of polyethylene glycol, also known as PEG. So these chemicals is then mixed with urea, 5 millimoles of urea, and dissolved in deionized water, under constant stirring to get a pH of around 5.5 pH. In another beaker, which is solution B, a certain amount of this D-glucose is dissolved in DI water with the aid of ultrasonification. So you have solution A and solution B. So then solution B is then slowly added to solution A, which is then stirred using magnetic stirring until both solutions will be a clear solution C. So basically the product solution C. Okay, so then this solution C, is then transported to a Teflon lined stainless steel autoclave sealed and kept at 200 degrees Celsius for 24 hours or 1 day under autogeneous pressure in an electric oven. As the reaction is completed, a gray solid powder is then formed, which is then washed several times with a mixture of ethanol and DI water and dried at 60 degrees overnight in a tray dryer device. Finally, any volatiles are removed using by calcining the product at 600 degrees Celsius for 4 hours under a nitrogen gas flow and 2 flow. All right, next up, we have the acid treatment for this catalyst production. The first step is to have the post-acid treatment is carried out in a reflux condition rather than in the nitrogen gas flowing. So 5 grams of synthesized mesoporous zinc aluminate is immersed in 50 milliliters of benzene sulfonic acid at various sulfonation temperatures ranging from 100 degrees Celsius to 200 degrees Celsius for 2 hours at a constant and stirring speed. Okay, and the third step is after finishing the process, the slurry is then rinsed and filtered multiple times with 80 degrees Celsius WI water, then dry overnight in a vacuum oven at 120 degrees Celsius to get a dry solid. And finally, this post-calcination is then carried out at 600 degrees Celsius for 4 hours in order to gain a pure sulfonated mesoporous zinc aluminate product.
So for chapter 4, for physical properties, the method used is thermogravimetric analysis, which is to determine the thermal stability, oxidation stability, and estimated lifetime of product. For example, which is sample is heated up to the 1000 C and change of mass is monitored. For chemical properties, which is X-ray diffractions, this is to investigate the crystallinity of post-calcine ZnL2O4 samples. This is for better and powerful technique as XRD can be used to identify unknown material in short time. For morphological properties, used for scanning electron microscopy, image is formed by a focused electron beam that scans over surface of specimen. Can see surface of any sample, examples industrial metals, geological and biological samples.
Alright, so for chapter 5, suitable catalytic reactor for the production of biodiesel. So we have chosen CSTR as the suitable catalytic reactor. A CSTR constantly adds reactants and removes product. Adequate agitation is essential to achieve homogeneous chemical composition and temperature. The continuous flow process in most situations involves extensive process controls and online product quality monitoring. When a CSTR is constantly run at a steady state, the concentration of any chemical involved should ideally remain essentially constant throughout the reactor. In practice, this ideal condition is rarely attained. As a result, operational settings must be changed to assure complete response. On rare occasions, more than one reactor is employed. For this technique, approximately 80% of the alcohol and catalyst are introduced to the oil in a first stage CSTR. Before entering a second CSTR, the reacted stream is treated to a glycerol removal process. The remaining 20% of the alcohol and catalyst are delivered to this reactor. When compared to a single-step method, this approach delivers a more complete reaction while requiring less alcohol.
Hi, my name is Ahmad Haris. So for the current trend of biodiesel production, for starters, the main source of biodiesel production is actually palm oil, which is one of our major economy in Malaysia agriculture industry. Palm oil led the agriculture sector's gross domestic product in about 37.7% shares, which is quite large in percentage in year 2020. The large biodiesel production has successfully avoided the dependency on petroleum, since the biodiesel can alternate the same functionality of petroleum with a greener option. Therefore, biodiesel is the future trend in energy resources until nowadays. With that, the demand is increasing. As a country that rich in tropical resources, Malaysia can generate a large amount of biodiesel, as Malaysia is one of the top 10 biodiesel producers worldwide. And for the production of biodiesel challenges, number one is the catalyst that affecting the end product of the biodiesel, which caused by improper procedures during the production. And second is, in order to deliver the production demands, deforestation needs to be done to make more area available for palm oil tree plantation, and this could lead to CO2 emission and resulting in air pollution in Malaysia. And last but not least, the palm oil trees plantation face a disease happen on the plant that is caused by virus causing the plant to rot and unhealthy. This disease is called the basal stem rot, and there is no remedy once the plant is infected. So in conclusion, the current trend in biodiesel production is improving all of the time. However, Malaysia must do extensive research and development in order to solve such challenges and compete with other countries while meeting the demand of biodiesel production. And that's all from us. Thank you.